Alrighty, let's take a look at this one. So if f is a differentiable function, which basically means that you can take the derivative of it, that it's continuous and derivative exists everywhere. Okay, find, which really doesn't affect the question much for what we're doing, find expressions for the derivatives for the following functions. Okay, so let's start with A. We're given g of x equals x times f of x. All right, so what I'm seeing here is that we have product rule because we have something with x multiplied by something with x. Just the second thing is a little more generic. So if we're going to do the derivative, we take the derivative of g of x, which we'd write as g prime of x. And then on the right-hand side, we're going to have to use product rule. So first, which is x, times the derivative of the second, which would be the derivative of f of x, we're just going to write as f prime of x, because we don't actually have the specific function for that. Okay, and now plus the rest of product rule, the second f of x times the derivative of the first, which the derivative of x is just equal to 1. And we can just clean that up a little bit, meaning we don't need the multiply 1 at the end. But other than writing it as g prime of x equals x, f prime of x plus f of x, not much else you can do. That would be the answer. All right, let's take a look at B. So we have h of x equals the square root of x times f of x. So again, we have product rule. We might want to think of that root x, though, as x to the 1/2. So I'm just going to get rid of that little root sign. Okay, now let's do a derivative again. So h prime of x equals, okay, so first, so x to the 1/2 times the derivative of the second, which would be f prime of x, plus the second, f of x, times the derivative of the first factor, which would be, we'll have to use product rule, or sorry, power rule on that. So we multiply, so we're doing x to 1/2. So multiply the 1/2 down front, and then decrease your exponent by 1, which would give you negative 1/2. So we would have 1/2 x to the negative 1/2. Alrighty, now as far as cleaning this up goes, you could leave it like that, but generally speaking, you don't want fractions and you don't want negative exponents. So we could factor out a fraction of 1/2 and factor out x to the negative 1/2, because if we do that, we'll get nicer terms inside, like whole number exponents and stuff. So if we're dividing that first term, x to the 1/2 f prime of x, by 1/2 x to the negative 1/2, the 1 essentially divided by 1/2 would become a 2 now. And then x to the 1/2 divided by x to the negative 1/2, you subtract the exponents when you're dividing powers. So that would end up being 1/2 minus negative 1/2, which would be x to the 1, so just x. And then of course f prime of x is still there, plus, and then the second term, f of x would still be there, but the rest of that would be gone because we divided by it, it would equal 1. And there we go. Oh, we could also write that like this. Put the 2 on the bottom, turn the x to the negative 1/2, move that to the bottom, write it as a root. And then we would have what's in the brackets would be in the numerator. So you could write it like that. Depends on how you want that. Okay, now part C. So part C says we want to do the derivative of f of x equals x to the c and then f of x. So they're keeping this very generic. Okay, but we do again have product rule. So let's do that. F prime of x equals, so product rule first, which would be x to the c times the derivative of the second, so f prime of x, plus the second, f of x, times the derivative of the first, which we'll have to use power rule on that. So the exponent moves down front. So we have a c, then sorry, messed up there. Then you would decrease your exponent on x by 1. So you would just have to write that as c minus 1. And there we go. That's pretty much it. I don't think we'd probably simplify that too much. And there you go. Hope that helped.